All right, so now you know how to use z-scores. But in the real world, we're dealing with real data that is normally distributed. And in order to use the standard normal distribution table, we have to take real data and calculate z-scores. So remember, the z-score is just how far you are away from the mean. How many standard deviations are you away from the mean? And so I've already given this formula, but I'll give it again because it's important. In order to figure that out, we're going to figure out the difference between the value and the mean, and then divide by the standard deviation. Okay, and that'll tell us how many standard deviations that particular data point is away from the mean. Then once we have the z-score for an actual value, then we can look it up in the table. Okay, and then we'll have the probability. So let's try that. So here we have a normal random variable where the mean is 100 and the standard deviation is 20. So we're given the mean and the standard deviation. And we want to know what's the probability of that normal random variable being greater than, or sorry, less than 120. All right. So the first thing we're going to do is just take that 120 and convert it to a z-score. So I'm going to take 120 minus the mean, which is 100, and then divide by 20, which is the standard deviation. And it turns out that's just 1. So, so the probability that z is less than 1, we can look that up in the table. 0.8413 is what I got just by looking it up in the table. Okay? That's basically all there is to it. That's the probability we want. So all we had to do is convert the actual value into a z-score, given the mean and the standard deviation. All right, so now in this case, we're asked to find the probability of the random variable being greater than 70, greater than. Okay, so now we have to do a little bit more work. But just remember what we just did. Okay, let's first of all convert it to a z-score. So 70 minus 100. Okay, it's always the data value first, right? Minus the mean. So we end up with a negative number because it's below the mean, right? So we end up with a negative 1.5, right? Which makes sense because it's below the mean. It's going to be negative because on the standard normal distribution curve, the mean is 0. So if it's below the mean, it's negative. All right, and so what we're going to do is we're going to use the symmetry of the table. The probability that z is greater than minus 1.5 is equal to the probability that z is less than positive 1.5. Okay, so we're just using the symmetry of the table. And now, because all of our values in the table are probabilities for z being less than something. And so when we look that up, we get 0.9332. Okay, and that's it. We're done. All right, so let's look at a case where we're trying to find the probability between a couple of values. So I'm just going to calculate the z-score for each one of those. So the z-score for 75 would be 75 minus the mean, which is 100, over the standard deviation, which is 20. And so I got a minus 1.25. The other z-score, corresponding to 110, is 110 minus 100 all over 20, which gives me 0.5. All right. So we just have to remember how to calculate that. We're going to take the probability of z less than 0.5 and then subtract the probability that z is less than minus 1.25. Okay, and what's left over will be the probability of it being between those two values. All right, so just look up the two values on the table. This one is 0.6915. The other one is 0.1056. Okay, just looking it up on the table, taking the difference. So the difference is 0.5859. All right, we're done. So it's really no different than the other problems that we were just doing where we're given z-scores. It's just that now we have to take the value and convert it to a z-score. All right, so let's take a look at this next one. All right, this is one of those where we have to do a reverse lookup. We're given a probability, and we want to find a value x such that the random variable is less than that x value. Okay, so let's first of all look up that probability. Okay, that probability is going to give us a z-score such that the standard normal variable, is less than that z-score. All right, so I'm just going to leave a blank here because I want to look up this 0.287. If I look that up in the table, what I find is that probability corresponds to a z-score of minus 1.90. Okay. So what I need to do now is find the corresponding random variable for the value I'm looking for. So I know that I could calculate the z-score, that 1.90, by taking whatever this random variable that I'm looking for minus the mean and dividing it by the standard deviation. Okay, so then there's a little bit of algebra involved. You know, I can multiply both sides by 20 and then add 100. So what I get is essentially that I get minus 1.90 times 20 and then plus 100. Okay. You can also think of it, if you just think it through, that z-score is the number of standard deviations from the mean. So we are 1.9 standard deviations below the mean. So you can also just think of it as you're taking the mean, and the value you're looking for is 1.9 standard deviations below the mean. So we're just going to subtract 1.9 standard deviations. 1.9 times the standard deviation. Gives you the same thing either way. If you prefer to think of it that way and not have to write the equation and do the algebra. Sometimes it's a little easier just to think it through. What does it mean? That z-score is the number of standard deviations from the mean. It's below the mean, so we have to subtract 1.9 standard deviations from the mean to get the z-score we're looking for, or to get the random variable we're looking for. So x is equal to 62. Alrighty, well, again, there's a lot of repetition in this lecture. The next example is one for you to try. It's essentially identical with different numbers to this example. So give it a try, and then watch the video if you need to, or just skim through it and get the answers and compare with what you get. So I'll meet you in the next video.